Hello, I'm Professor von Schmohawk, and welcome to YU. When we first introduced the concept of exponents, we saw that any number a raised to the nth power, where n is a positive integer, is equivalent to n a's multiplied together. This is true not only for numbers and variables, but it is also true for expressions. If we enclose an expression in parentheses, we can raise the entire expression to a power. This is equivalent to n copies of the expression multiplied together. For example, let's say we take the expression a cubed and square it. This is equivalent to 2 copies of a cubed multiplied together, which is a times a times a times a times a times a. Of course, 6 a's multiplied together is a to the 6th power. Notice that the exponent of a times the power this expression was raised to equals the exponent of the result. In general, if we start with a with an exponent of m and raise that expression to some power n, this is equivalent to n copies of that expression multiplied together. Since these multiplied expressions have the same base, we can add their exponents. This gives us an exponent of n m's added together. M added together n times is m times n. So the result is a to the m times n power. So as a general rule, if we take any term with an exponent of m and we raise that exponential term to the nth power, we can multiply the two exponents. For example, if we take 10 squared and cube it, this is the same as 100 cubed. And 100 times 100 times 100 is 1 million, which is 10 to the 6th power. Likewise, if we take 10 cubed and square it, this is the same as 1,000 squared, and 1,000 times 1,000 is 1 million, or 10 to the 6th power. So squaring 10 cubed and cubing 10 squared both give the same result, 10 to the 6th power. This makes sense because when we multiply the exponents 3 and 2, or 2 and 3, either way we get 6. Now what do you think would happen if we raise an exponential term to the 0 power? If we raise any exponential term to the 0 power, when we multiply the exponents, the result will always have an exponent of 0. So the result will always be equal to 1. So just like numbers and variables, any exponential term raised to the 0 power is equal to 1. So far we have seen that any term with an exponent of m raised to the nth power is equivalent to that term with the 2 exponents multiplied. But what if one or both of the exponents are negative? Will we still get the correct result when we multiply the exponents? Let's see what happens when we take a cubed and raise that expression to the negative 2nd power. Remember that anything with a negative exponent is equivalent to 1 over that thing with the same positive exponent. So instead of a cubed to the negative 2, let's write 1 over a cubed to the positive 2. Now, multiplying the exponents, we get 1 over a to the 6th power, which is the same as a to the negative 6th power. Since 3 times negative 2 is negative 6, so far our rule of multiplying exponents works. Now let's try the same problem, except this time we'll make the other exponent negative. We'll start by rewriting a to the negative third as 1 over a cubed. And squaring 1 over a cubed is the same as 1 over a cubed times 1 over a cubed. To multiply these fractions, we multiply their denominators, and we get 1 over a to the 6th power, which is the same as a to the negative 6th power. Since negative 3 times 2 is negative 6, it looks like our rule for multiplying exponents still holds. Now let's see if our rule works when both exponents are negative. The term in parentheses has an exponent of negative 2. So let's rewrite it as 1 over the same term with an exponent of positive 2. In the previous example, we found that if we square a to the negative 3, we get a to the negative 6. And 1 over a to the negative 6 is the same thing as a to the positive 6. Since negative 3 times negative 2 is positive 6, we have showed that our rule of multiplying exponents works whether the sign of either exponent is positive or negative. So far we have seen that any term with an exponent of m raised to the nth power is equivalent to that term with the two exponents multiplied, and that this rule holds regardless of the signs of the exponents. In the next lecture, we will see what happens when products or quotients of exponential terms are raised to powers.